Good morning and good day, everyone, and welcome to our first 2024 lunch break webinar, hosted by Ejlskov in collaboration with AST Environmental, our remediation partner in Kentucky, US. Today, I'm joined by Mike Mazzarese at AST Environmental. My name is Giorgio Ceriani from Ejlskov. We'll go through the agenda for today. We would like to introduce a bit what we will talk about during our following events within this series, a bit of introduction about where we come from with the RPI group, and then go through the topics of today, which is understanding of the difference between qualitative and quantitative data for improving our site CSMs, the tools that Ejlskov and RPI have available, including their services when it comes to delivering services to clients. Some case studies to cover the short-term and long-term benefits when it comes to the use of high-resolution site characterization and remedial design. And then a little deeper dive into more broader and wide case studies and the lessons learned we have from pretty much 25 years of operating with this approach. And we will try to leave as much time as possible for a question and answer session. Just a little housekeeping. So if you would like to post and ask questions, depending on the browser you're using, you may have a Q&A bar appearing at the top of your screen or at the bottom of your screen as you move your mouse. You can activate your Q&A chat and just drop some questions over there. We will go through at that time. As we mentioned, we will have some follow-up sessions. For the spring, we are going to be focusing on a second session that will cover the follow-up pretty much of what we are talking today, which is moving from the design of a remediation to a correct in-situ application. We will share case studies and lessons learned over the past 25 years. This will be on March 5th, again at lunchtime. And here we will discuss pretty much what it means to have the right tooling in place for a correct application of a slurry, of a reagent, and the misconceptions that have been probably created within the industry over the last years regarding pressures and flows and what it really means to provide a good application and a correct installation of the product selected for your remediation. And as we discussed, a bit of background of where we come from. As Ejlskov, the company was founded in 1999, and based on our, let's say, location, we are out of Aarhus, Denmark. We have been active across the Nordic region in Europe since then, but we have covered all of Europe, China since 2015-16, and we have provided all the services related to high-resolution site characterization and in-situ remediation. Since 2010, we have become part of the RPI group with the trap and treat technologies and became a licensed installer for RPI. And recently in 2022, we have become also licensed installer for the fluorosorb technologies for PFAS contamination. When it comes to Ejlskov, we try to provide total solutions to consultants and clients. We have a wide variety of tools available. Our group consists of engineers, geologists, and you name it, any sort of technician who has a lot of experience when it comes to in-situ remediation of all sorts of kinds and techniques, and what it takes to have a proper design when it comes to in-situ remediation. And I'd like to introduce now Mike Mazzarese, who can talk a little bit more about RPI.
Thanks, Giorgio. Good afternoon, everyone. Giorgio's lucky that I'm a morning person. It's 4 a.m. here in Denver. So Denver is where RPI is located. That's where I'm based out of, and it's where RPI's project support laboratory is located. And as you'll see there in the next bullet, we've run many soil samples ever since the company was founded over 20 years ago, and run soil and groundwater samples pro bono for our clients, as you'll see in today's presentation. And they are the developer and the R&D wing for the trap and treat products that will cover mainly in the second version of this here in a few weeks. But as you can see, millions of kilos of the products have been installed now in 5 continents, and we have a very high return client rate, as you'll see there. About 95% of our clients who have used these technologies have come back to us for additional work. And so, and just to touch base on the Setco technology, we're not going to cover that really here today. We can focus on that a little bit in the next webinar. But as Giorgio mentioned, that is for PFAS sequestration. And just one note on that as it relates to today's presentation, all the analytical that we'll be talking about today is not focused on PFAS. Now you can use some of the same techniques, but the RPI laboratory does not run PFAS analytical. So just one note on there as we move forward. Giorgio, back to you.
Thank you, Mike. So we can start now diving into some of the technical aspects of this webinar. We will go through the difference between when we look at qualitative data versus quantitative data in terms of trying to improve the site CSM. So the approach that Ejlskov and RPI have tried to follow over the years when it comes to delivering a total solution for consultants and their clients is to pretty much introduce, as we see into this slide, a remedial design characterization step. So most of the times when sites data is provided to us, we see that there is a lot of compliance data available, but sometimes there is not sufficient resolution to be able to provide a surgical remediation plan that can guarantee the client a predictable outcome of the in-situ efforts. So we normally take all the data available that can be soil, groundwater, some direct sensing data, throw them in our model, 3D model software, which I'll show later, and try to set up their remedial design characterization plan. What that means is that we look at the data gaps present in the CSM and how those data gaps affect the outcome of our remediation planning. And with the remedial design characterization phase, we go and fill those data gaps by collecting high density, high resolution data, both by use of qualitative tooling and quantitative tooling. And that exercise allows us to be more precise in defining what the final remediation plan will be, and also sometimes being able to approach the authorities with better options for describing what the end goal can be for a remediation. And then we move to the active remediation phase, which is now conducted in a lot more efficient way, thanks to the high volume of data collected in the previous phase. And also the follow-up monitoring after the remediation can be done in a much better way, because now the amount of data available pre-remediation is so high and significant that anything that we want to compare against the performance of the remediation can be done, being soil data, being groundwater data. We do not suggest qualitative data as one of those things because it's, again, qualitative, but we will look at that later, what that means. And so we get to a successful, let's say, end of our projects. And in, again, a quick slide, we try to show that concept. So here we have a site that was given to us where the CSM at that moment from the client was truly the map that is shown in the top left corner, with a hotspot that was defined, a pump and treat system that had been running for a few years, but unfortunately no results were being achieved. When we came in with the initial MIP screening, what we found out is that that hotspot that was previously identified was unfortunately not the source of the contamination, but that source was located elsewhere on site. And that guidance from the MIP allowed us to then go and collect all the necessary soil data at high resolution to be able to create a fine-tuned CSM and mass model, as we can see below, where the signal of the MIP is now quantified by, probably in that case, we had 300 plus soil samples, and we could see that there was a clear layer of DNAPL causing the problem at the site, which could not be resolved until then. So conceptually and rationally, what we try to do with this exercise of going from qualitative to quantitative and high resolution data collection is to engineer our solution. So the more data we gather, the safer we can go from A to B when it comes to reaching success for a project. So how do we achieve that? And here are the tools and services that we provide. So a quick look at what kind of machines and equipment we have at Ejlskov for conducting high resolution site characterization. We have geoprobe machines available. We have 3, let's say, large machine capable of reaching 30+ meters of depth, depending on the geology. We have a mini rig that is capable of entering office space if we want to do indoor investigations. We have a tiny little hollow stem auger drilling machine. And most importantly, since we respect the safety standards that many clients have, we decided to invest in a vacuum excavation machine for clearance of underground utilities. We support the drilling machines with direct sensing tooling like the MIP probing. We have also low-level MIP if we want to go and screen some low contamination plumes. We have EC probes and PST kits for assessing soil conditions and hydraulic conductivity conditions at sites in a fairly quick and reliable way. We can provide the MIP, HPT, and OIP as needed if clients require. And then we run the soil coring by use of dual tube direct push tooling. We have microcore system, hollow stem augers for installations of wells if needed. And we can provide SP16 tooling and soil gas probing. Within the RPI group, we have a strategic partnership, which allows us to get access to different companies for different type of drillings, let's say bedrock. But most importantly, we have developed a team that is extremely good at investigating and remediating bedrock. So we have a lot of experience with that. A little touch on the mini rig so that you can see what we are talking about. So we have been doing MIP investigation, wells installation, soil coring, and also injections within confined spaces, being basements, being offices, being in this case, car dealer active shops. And what these machines allows us is to really fill in some of the critical data gaps when it comes to some of the active sites that you may find anywhere. So it was just a few pictures to show that sort of feature. The MIP, maybe many of you already know most about it, but what it is, it's a tool manufactured by Geoprobe for detection of volatile compounds in the subsurface. What it consists of is a probe that is heated to about 120, 130 degrees Celsius. You have a gas line that goes from the instrument, the GC mass spec, up to down to the probe and back up again to the instrument, where we pretty much strip out any contamination present in soil by using the heat out of the probe, and the nitrogen gas passing through the trunk line will carry any contamination that is desorbed off the soil or the groundwater back into the GC equipment, and giving us a profile of what kind of level of contamination we may be expecting at a specific depth. So this allows us to get guidance of where to sample soil or groundwater. This is important to mention that the MIP is a qualitative tool. It's not you cannot quantify the contamination. It's purely an indication of what kind of type of contamination you may have. So this is an example of a chlorinated site where the XSD and PID sensors have been reacting where soil contamination was found. Then from the EC profile, we can see the difference in soil. So we went from a silty formation to a clay layer back into a sandy silty formation where the aquifer was present. And that corresponded with another spike in the sensors where we could see the groundwater contamination. So those are all information that we gather in our model and then define where to collect samples. And these are the list of compounds in the bottom right corner that RPI can analyze for us when it comes to VOC sites, from chlorinated to hydrocarbons to fatty acids and anions when it comes to groundwater. Same for dissolved gases, which are all good indicators, for example, for biological degradation. And what do we do with all that data? We have developed over the years in-house software, which we have called the ESM, Environmental Site Model. And the beauty of the software is that it kind of learns from any client request. And we have tried to always support clients in getting whatever outputs they needed. So here is an example of a site where we had a lot of soil data available. The client needed to do some mass calculation, and the software in a split second can throw out any sort of mass estimate of what kind of volume you're dealing with below a specific threshold, between different type of thresholds. And all that information then can be used for risk assessments, remediation design, construction planning, how much mass you need to excavate. A lot of outputs can be taken out of this software. How does also this translates into short and long-term benefits? Here's a few case studies. So we start from a typical redeveloper site. So this is a site in Sweden where we are actively working over these years, and in the future we will do a in-situ remediation. So this site was started with the assumption that based on the historical information from the client, they would have used TCE only in the area that where the two cross sections sort of merge. We started with a baseline MIP investigation of roughly 13 points. At some point, the client saw that the groundwater results weren't really matching with where we thought the only source was. So we decided to extend the scope of work because the site was then being totally redeveloped and demolished to start with. We ended up performing 120 MIP points in total at this site. We drilled roughly 3,000 meters with MIP probing. And we collected 700 soil samples, which were analyzed free of charge. So as we can see, the output of this exercise on the short term was to allow the client to see exactly where all the possible sources of contamination came from: sewage leaks, any sort of production area that they may have sort of forgot about it over the years. From a groundwater and soil contamination standpoint, we were able to then create a remediation plan that allowed the client to think strategically when it comes to the demolition and redevelopment of the site, so that areas that were deemed to be fully cleaned could be already processed in terms of planning and preparation of the site. Whereas when it came to, for example, the soil contamination, we decided to focus by use of soil mixing because of the depth, because of the type of soil. When it came to the groundwater plume, the plan for this site is to follow what the authorities are demanding, which is a risk mitigation control of the plume migration off site. And as you can see from the cross section below, we have designed a remediation injection plan that covers that plume from possibly creating issues off-site. The cost saving here, you can imagine when you talk about 700 soil samples, you can easily quantify the amount of money that the client saved to achieve this result. Another reason why remedial design is extremely useful is because sometimes you don't have much information about the geology of the site and what it's gonna be like when you go out and do a remediation. In this case, we were asked by a client to solve a hydrocarbon issue. So we had benzene and MTBE leaving the site, migrating towards the lake nearby at the site. We went in this case, we didn't have the MIP available because it was booked on other projects. So we had to rely only on soil coring. And the good thing about doing soil coring at this site was that it allows us to understand that we were dealing with highly homogeneous sands all the way down to groundwater, which sometimes are not easy to drill through with direct push. But that exercise then told us, okay, for the injection, we will need to do something different. And that was a good exercise because then we went through a pre-drilling exercise to prepare the injections. We went through those 11 meters of dry sands, prepare all the points, perform the injections, and this site then achieved the expected results within months, and we closed this case quite easily. Sometimes it's not just injections that we like to do. Sometimes clients are forced to have other solutions in place. This was a case of a truck stop where the client had to do a knockdown and rebuild of the station. At that time, they had an initial understanding through historical investigation that the possible area that needed remediation was roughly 200 square meters. They may have had to dig down to about 9 meters. leading to approximately 1,700 cubic meter of soil to be disposed. This client had been performing an injection remediation with us at another site, so he decided, let's use the remedial design concept to try to narrow down the amount of volume that we will need to excavate during this knockdown and rebuild. And that exercise led to a reduction in cost when it came to disposal of almost half of the amount that was initially planned. And how did we achieve that? Again, by collecting high resolution data showing then the authorities that we had a perfect picture of where the contamination started, where it stopped, laterally, vertically, and that helped the client making a much more predictable excavation plan. Mike, would you like to share a couple of words about one of your cases?
Sorry, I was muted. Yeah, so this is an example of a really small project here in the US, where as little as we used 5 investigation points, client had budget for really just 1 day of investigation. And so we were able to get that work done in just 1 day. And then you can see the pre-injection design in the upper picture versus the lower picture, which is what our design ultimately looked like. We were able to carve the site up into more sub areas, which really helped us optimize where the product ended up going. And I would say on not all sites, but I would say most for sure, that the cost of the additional investigation, so obviously the analytical was covered by RPI, but the cost, the field work and the shipping is going to pay for itself in that optimization phase. And I went through and ran the numbers on this project here, where we had our preliminary design based on 11 field days and about $153,000 US budget, and we were able to save the client close to 20%, even when you factor in that RDC, because we were able to. The main cost savings was in that treatment thickness that you'll see in that third column, and that most designs, when we have very limited data, are based on what's in groundwater over a certain, say 3-meter screen, and maybe one soil sample, and that soil sample could be old as well. So we have to make conservative assumptions in our designs, but when we can peel those safety factors out once we have these dense data sets. And so I would say that savings that you see there is fairly typical for most of the projects that we work on.
Thanks, Mike.
Of course.
Now, again, we'll pass on to other case studies again and what the lessons learned of those case studies are. Here, again, we can look at for example, how we went from high resolution to a detailed construction planning with the redevelopment company involved with this project and his consultant. So here we started with a sort of, let's say, carte blanche, and the CSM at that time was mostly driven by soil gas data. The initial thought from the team was that possibly sources of contamination could have been in the northwest side of the building due to high levels in the pore gas. When we went in with the MIP, the client was actually very proactive in allowing us to screen the property from east to west and north to south fully, because they wanted to be 100% sure that after demolition, they would have not had any surprises when they started to dig for the construction of the parking and things like that. So what this exercise led us to do was 58 MIP points, about 20 soil cores, roughly 300 plus samples collected with an additional investigation that was done prior to the remediation in the source area. A large number of groundwater samples were collected over the lifetime of this project. But here, the beauty of this exercise was that the construction plan for this site was, once the building had been demolished, to dig down to 4 meters and build an underground parking. So when we found the Dean Apple source at about 3 meters around an old oil water separator, it was quite clear for the team that there was no reason to do in-situ treatment before the 4 meter mark, just because that soil would have been removed anyway. So we focused our attention of the injection on the plume, on controlling the off-site migration, which was quite high when it came to the concentration of TC at this site. So it was a great team effort because it showed how every stakeholder involved in the project can have a big impact in providing critical information that are useful for the outcome of the project. And here as well, then all the information from the construction team, the consultant, and our side were all thrown into our software, so everything could be easily visualized by, for example, the authorities during the planning phase and execution phase of the remediation, and everything is kept tracking here. When it comes to active sites like gas station, this is an example from an active site where a full rebuild was performed in 2007, so USTs were dug up, the site was reopened, but unfortunately there were still high levels of BTEX and TPH leaving the site in groundwater, and also pockets of El Napo seen on site. Despite 15 years and multiple events of investigations, the picture that you can see on the left show where we were before entering within a high resolution event. On the right, you see the full output of what the remedial design told us. And you can see that sometimes those data gaps that you may not know can be found, and the impact is quite important. And how does it translate in number? In that specific case, we had a clear view of the problem because we had a difference in mass that was found both for the BTEX and the TPH. And again, here, ultimately, all the data is thrown in the model, easily visualized by all stakeholders. You can throw in also the information about the infrastructures and so on. And that allows everybody to understand exactly what the dynamics of the contamination on site is. And this would be a site undergoing future remediation quite soon. From a soil mix standpoint, we have cases where, again, we thought we were going to go in with injections, whereas after, again, a remedial design, we found out that the delineation of the contamination and the type of soil would have rather led to a different type of approach when it comes to the final remediation implementation. And again, here, this was a site that started with a basic amount of information. We enhanced that understanding of the site, and then treated this site with, again, the same technologies that we normally use for VOCs, but applied as a soil mix rather than an injection. Another case here would be when direct sensing may not be the best tool to use for HRSC. And in this case, we had PAHs as an issue. You could use OIP, but OIP to be successful with PAHs needs high concentration of PAHs in soil and groundwater, which may not be the case all the time. This was a site with a very long history. The contamination came from probably 80, 100 years ago. So we told the client, we can try to bring out the direct sensing tooling on site, see based on your historical information if the profiles match. If not, we will provide the same service of high resolution, high density data with soils. And here, exactly, that's what we did. We allowed the client to collect as many soil samples they wanted on 30, 50 centimeter intervals. And the output provided was such that the risk assessment for the client was with less, let's say, unknowns compared to what it could have been. And a final case study is a full, let's say, complex site where we started with a chlorinated plume that, despite the excavation and removal of PCE tanks, had been causing the client troubles for 10, 15 years. They tried to install a pump and treat between the building and the site boundary to control that plume, but they just couldn't handle the issue. When we came in with the high resolution remedial design, we actually found out that there was a large pool of DNAPL that had never been discovered, and that what led the final strategy of the remediation. And you could see from the numbers that the miss in terms of how much mass was left in the ground was pretty big, because we were talking about 16,000 kilos of PCE. This led to a large injection that was performed in 2017. And the results of that exercise and investment in the RDC phase is quite clear, because now we have a plume that is completely imploding after 6 years post-injection. We don't see any more DNAPL at the site. Most importantly, the client has been able to save large amount of money through free analyticals for the post-remediation phase and also for the soil analysis during the RDC and validation phase performed in 2022. And all that is also translated in how we see the results also from the end side of things when it comes to biological degradation. So this being a chlorinated site, we would expect to see ethylene being generated. And again, the RPI data allowed us to create a high resolution post-injection model of how that plume is looking as of today. And we would like to thank you for your time at the moment, so we can open the Q&A session. As mentioned, you just move your mouse to the top or the bottom of your screen, and you should be able to find your Q&A chat where to drop your questions. While we do the Q&A session, we will also play a couple of clips to show how our ESM model works and what kind of outputs you can expect from it.
Well, Giorgio, while we're waiting for questions to come in, I'll go ahead and ask you one. I guess it's if you can elaborate on that pre-drill technique a little bit, because that's something that we'll obviously talk about in the next webinar, but I feel like it's worth mentioning today as well.
Yes, so what pre-drilling means is that when using direct push technique, one of the main challenges of direct push is, for example, dry sands, because they create so much friction around the pipe. So in those kind of challenging geologies, just because you cannot advance direct push in the first place, you shouldn't just give up. So in that case, what we were able to do was to advance a rotary rotopercussion tooling down to the targeted depth. In that case was about 15 to 17 meters, depending on the area at the site. By opening up the borehole, then we were able to fill it again with bentonite pellets and grout. And directly after the hole kind of got fully sealed, then we would go again with the direct push tooling and start injecting at the required depths. So that's how we use that technique to expedite the process in challenging geologies. You can see that one maybe was cut off question because we can only see hi, but then there is blank space. Maybe somebody tried to post. There it comes. We have a I wanted to leave the question why remediation methods mostly are based on dredging and why other more advanced in situ remediation are not so widely used, at least in Sweden. Mike, what's your experience? Because you probably have a little more, even if I got some.
I do not. I mean, if you're specifically referring to like sediments, is that where you?
Yes, that is what we are talking about, sediment dredging versus in situ remediation methods. What would be our take on it?
I mean, sediments are not my expertise. I'll just be honest with you, and that's not something that we really get involved in at our PI group. I mean, you could use some of these same techniques, some of these same high-res techniques. For example, we've sampled below, creek beds or stream beds, which would be somewhat similar, but really have not taken these techniques and translated them into some sort of sediment sampling program. But I could see that they could. Now I don't know. Now I know that folks have used like the MIP and those sorts of technologies off of like barges, and obviously drilling gets done on off of barges. So I mean, you could theoretically translate that into a more sediment focused sampling program. That's not something that we've really been involved in, but maybe the best thing to do would have a specific example, Giorgio, of where we have a site where we could go in and kind of look and see how we could how we could translate what we do in a normal subsurface situation to a potential sediment problem.
From my side, I can only add, we had a slide, for example, the one where I showed the first features of the of our software, where there was that example with the mass calculation. So we know from discussion with the consultant that the same client may have the same problem with the same contaminant on a coastal site, and they will probably ask us to find a solution again to collect high resolution, high density sediment samples, maybe off a barge, depending on the depth of the bay and the characteristics. But again, the idea then is collect as many data as possible within one mobilization and try to optimize the output in terms of distribution and how that specific contaminant is present in the subsurface. And there is also follow-up work in environmental design and environmental consultants suggest. Okay, so the follow-up on this topic is also that there doesn't seem much suggestions of other method than dredging. And again, we may have to go deeper into it in another session when it comes to the application technique on what we do sometimes with soil mixing, and could that be applied to sediments? It could be a possibility, and we will try to maybe show some cases that could be useful for consultants and clients to sort of gather some inspiration from. See if we have more questions coming in. We are happy to answer any. If you have any comments, or just shoot them out. No hard feelings, definitely. Let's wait. I guess, Mike, while we wait, maybe some also some comments. Oh, maybe one just came in. Yes, here it comes. Have you applied in-situ injection works in crystalline fractured rock? Mike, I think you guys have done pretty much any sort of bedrock work.
Right. Yes. So here in the US, we've done, and we actually have a table that I can send to Giorgio that he can follow up with you on that over the last. So we do injections with straddle packers, and we probably started doing that work about 11 or 12 years ago, and since then have built up. We do. It's probably the least application technique that we use, because it's those sites tend to be pretty large and complicated, and the upfront geophysical work that's needed to really properly characterize a site is not always done, and so that's the first step that we get involved in. But I do have a table of all of the bedrock sites that we have worked on, and it lists the specific geologies for each of the sites and what was ultimately done. So I can go ahead and get that to Giorgio after the call, and then he can go ahead and follow up with you. And so we don't specifically have we don't specifically talk about bedrock, or we didn't really plan to in the next webinar. Maybe touch on it briefly. But what I could also send are some links that, so AST during the COVID lockdown did a series of webinars, and one was specifically on fractured bedrock characterization, and there's a second one that follows that was specifically on fractured bedrock injection and remediation. And so I'll go ahead and send Giorgio the links for those webinars, as well as that list of sites, and to help you answer that question.
Because then on all our let's say web pages and even YouTube channels, we have all these available webinars. This will also be posted in the upcoming days, weeks, so you can just go on RPI, Trap and Treat webpage, and there is list of webinars that have been performed. AST Environmental has a large library as well. Ejlskov has some on their webpage, and so are on the YouTube channels, for example, of AST Environmental. Let's see if we have more questions coming in. And maybe, Mike, what I was thinking of discussing briefly while closing the time at our disposal was, I guess the US has been a little bit always upfront in terms of developing more, let's say, in situ sustainable solutions. What is your expertise or take after so many years?
On the sustainability aspect?
On the yeah.
Right. Well, I would say most, and we're actually in the process of being able to sort of quantify this. We've got several clients, like major oil and gas clients, that are actually looking at this, looking at reagent and technology application selection based more on, focusing on sustainability. And most of these applications that we get involved in, and I think, Giorgio, I'll let you comment after this, but most of the sites that you saw today and most of the sites that we work on are with one application. There's the occasional site that we do have to go back to. And so it's obvious when you compare that to things like, mechanical systems, pump and treat, things that have O&M and, disposal. But I think even when you look at it from, if you're looking at comparing specific reagents in situ, I think we've got a track record across the board of various products, various trap and treat products, where again, most sites, depending on, your baseline and depending on what the goals are, you may need to come back and do some polishing work, but the vast majority of our sites are with one application. And I think that is going to give you a much lower carbon footprint as compared to other technologies where you may have to come back on a more regular basis.
Correct. We do have a question that came in. So the question asks, in Sweden, regulatory compliance sampling and monitoring is usually carried out by third party, the client's consultant. How do you deal with these situations given that you carry out your own sampling? I may have misled maybe in some of my comments during the slide. So most of the sites where we do the high-res remediation design, we do suggest collecting all the high resolution data for RPI, but we do not deny any client and their consultants to collect compliance data of the same course. So we normally suggest to get maybe, let's say, 10-15% of the total expected volume of samples that can be collected for, call it Eurofins, ALS, the big names in the laboratory market, and get confirmation data. When it comes to the post remediation, most of for example, that site, the chlorinated site where I show 6 years of data being collected, that's all done by the client's consultant. We provide the service where we just organize the shipment and documentation so that the consultant can pack the samples, put them in a cooler, send them over to the US. The client only pays for the shipment, which is fractional compared to the value of the sample. So RPI package, you were looking at maybe a 250 to 300 euro value when you compare it to what a commercial lab would deliver. So the moment that you start looking at a shipment that may cost the same amount of one sample, then you see straight away the cost saving as soon as you have a monitoring plan involving 20-25 wells every time. So we do not interfere with the process. So we are happy actually to see consultants helping us, both collecting samples for RPI and validating that data from RPI through commercial labs. And yeah, if there's any last minute questions, otherwise we'll start to wrap up for today. I think seems like everything is sorted out. Well, then we would like to thank you again for the time that you've given us to explain what we do, at least for the higher-res part. Again, here our email addresses in case you would like to touch base directly with either me or Mike. We welcome you again to the March event on the 5th, looking at application and what it means in terms of providing results for our clients. Thank you, Mike, for your time, and hope you can get a good start of the day. And we'll see everyone and hopefully more participants even on the 5th of March. Thanks a lot, and have a good day. Bye.
Take care.